Swayam Prabha. Digital India. Educated India.
Namaskar. So, today we will continue our yesterday's discussion on mesh analysis. So, let us first understand what we discussed yesterday. So, yesterday we saw what is mesh analysis, and we stabilized the difference between the mesh current and the branch current, and we also saw that the every loop cannot be considered as mesh, because mesh is that loop which does not contain any other loop within it, and we also saw that the mesh analysis can be done with the help of Kirchhoff voltage law. Yesterday we also discussed that the mesh analysis is only applicable to circuit that is planar. Planar means the circuit which can be drawn on a plane and it does not have any branch which are crossing one another. So, like in this case, if you see, it is not a planar circuit because it is not drawn on a plane, it is something like 3-dimensional structure. Similarly, here also we saw that it is crossing the branches, but we can reorganize and make it as a planar circuit, and we saw that the 3 steps are required for the mesh analysis, where you will first define the mesh currents, then you apply KVL or at each of the n mesh, and then solve the n simultaneous equations. We took this circuit and we stabilized that these are the equations which are the outcome of our mesh analysis, and then we can finally solve it and get the answer. We also discussed that suppose if we do not know whether we have got equal means the required number of equations or not, that can be stabilized with the help of theorem of network topology, which says that number of branches equal to number of loops plus number of nodes minus 1. So, in the previous figure the nodes were number of 3 and branches were 5. So, we got number of loops equal to 3. So, that means that we need minimum 3 independent equations to solve this circuit, and then we discuss the example which was essentially a DC circuit, and we stabilized that the current in 5 ohm resistance is 0.44 ampere and 1 ohm resistance is 0.69 ampere. Now, let us talk about another example. Now, this example is not the DC network, it is related to AC network as shown in the figure below, and now the objective is to determine the mesh current I1 and I2 and the current flowing in the capacitor and active power delivered by 100 voltage with reference phasor as 0. So, we will use this circuit and try to apply the mesh analysis technique and find out the result. Now, in this particular case you can create 2 loops, because these are the 2 independent mesh which you can create. So, let us say that in this particular mesh the current is I1, in this mesh is current is I2. So, we can write 2 equations for both of the meshes, one for each mesh. So, for first mesh, if you see the current which is flowing in this particular mesh, you can apply Kirchhoff voltage law and find out the governing equation of this particular mesh. So, we start with the 5 ohm resistance. So, if you say current is flowing in 5 ohm, so you can simply write 5 into I1, then you are going from minus to lower voltage level to upper voltage level. in the case of voltage source you will simply write 100 angle 0 degree for this, and then this current will flow through capacitor. So, you will write minus J4 into I1 minus I2. Why minus I2? Because I1 is in this direction, but I2 is flowing in opposite direction. So, for this particular capacitor you will have net current as I1 minus I2. So, now you got this equation. If you rearrange you will get 5 minus 4j into I1 minus of 4j I2. So, this will become plus, and then 100 would be at the other side. So, you will get first equation for the mesh 1. Now, if you see the second mesh, the equation you can write, if you start with 4 ohm, you can say 4 into I2 plus 3 j into I2, and then you come here minus 4 j into I2 minus I1, and that would be equal to 0. If you rearrange, what you will get? You will get 4 plus 3j minus 4j into I2 minus of 4j I1. So, if you rearrange this equation, you will simply get this equation. Now, what you have to do? You have to just simply rearrange in such a way that you can solve it. If you rearrange and solve this equation, the current I1 which you will get is 10.77 angle 19.23 degree, and I2 10.45 angle minus 56.73 degree ampere. Now, here you can see that the result would come in the form of rectangular coordinates, where you will have real component as well as imaginary component. So, using your previous knowledge of phasor calculation, you can find out the value of these currents in terms of phasors also. Now, next is what is the current flowing in the capacitor? The current flowing in the capacitor would be I1 minus I2. You just simply take the difference of both of the currents, and you will get the current which is flowing through the capacitor. Now, next, the source power, that is basically the active power you need to calculate. So, active power is nothing but V I cos phi. Here voltage V is a reference phasor, because its angle is 0. So, we are considering it as a reference phasor, and then you have to simply put the value of current. Current would be what? Current is flowing from the source. So, what is the current? Current would be essentially the value of I1, because this is the current which is flowing from this particular side. So, you put the value of V and I. Cos phi is nothing but the angle for current I1. So, you will get source power delivered as 1.16 watt, 1.16.8 watt. Now, you can do verification also, like if you are interested to find out whether our power calculation is correct or not, you have to simply check the circuit. Here the active power can only be absorbed by the resistor 5 ohm and the resistor 4 ohm. So, if you want to know that what the power, active power being delivered by the source, you have to simply find out what the power being absorbed by these two resistances. So, now power in 5 ohm resistor is nothing but I1 square into 5, because if you see the current flowing through 5 ohm resistance is simply I1, and here for 4 ohm the power the current flowing is I2. So, you have to just simply put the value of I1 in case of 5 ohm. So, I1 square into 5, you will get the value of 579.97 watt. Similarly, for 4 ohm resistor, the power absorbed by the resistor would be I2 square into 4, and that would be 436.81 watt. So, therefore, the total power, you have to just add both of them and you will get the same value as we calculated previously. So, in this way you can cross verify that whatever you have calculated in previous case is correct. Now, another example which you can take, and this is very common example you will see in books. This is balanced star connected 3 phase load, and we need to determine the value of currents flowing through R, Y and B phase. So, here also we can apply the mesh current analysis. The voltage, line to line voltage, that is voltage across these two terminals is given as 415 angle 120 degree, and between these two nodes is 415 angle 0 degree, and this is balanced 3 phase load. So, the impedances across the loads is 3 plus 4j ohm. Now, we have to apply mesh current analysis. So, we will have essentially two meshes which we can create. Say let us say that in this particular mesh current is flowing as I1, in this mesh current is flowing as I2. So, now the two mesh currents you can use and apply KVLs for both of the loops. For loop 1, if you apply, what will be the value? So, I1 is flowing through this. So, this will become 3 plus J4 I1 plus 3 plus J4 I1 minus I2, because I2 is also flowing, but in opposite direction, equal to the voltage across the two nodes. So, what we get, that is I1, and for second resistor it is I1 minus I2, and that is equal to the voltage across those two nodes. If you simplify, you will get this equation. Similarly, for second loop also, if you solve it, if you write the equation, then for this only I2 is flowing, but for this the current is I2 minus I1. So, you will write again equation for the second node, and you will get this particular equation. Now, you have both of the equations available. You have to just solve these two equations, and you will get the values for current I1 and I2. Now, line current which you will see in this figure, IR is nothing but I1, Y is nothing but I2 minus I1, and IB is nothing but minus I2, and thus you can verify from this figure, because this current is in this direction. So, IR is nothing but I1. Here if you see IY means this is I2 and this is I1. So, IY would be I2 minus I1, while IB would be simply minus I2, because the direction of this particular, if you say direction of the IB is opposite to I2. So, you will write IB is nothing but minus of I2, and IY would be I1 minus I2 minus I1, because I2 is in the same direction of IY. So, this you get, and you can simplify by putting the value of I1 and I2, and you will get these results. So, this would be a very important example for you, because most of the time you will see in the electrical circuit analysis you would be given these kind of loads to identify the line currents which are flowing across the line terminals. Now, let us come to another important concept of mesh analysis, where the source is not simply a voltage source. Here source is the current source. Now, if you apply mesh analysis to the circuit only the current source, it looks that it is very complicated. If you see this figure where current source is there, voltage source is also there. So, at first instant you see that this is a little bit complicated circuit and difficult to solve, but actually it is much easier than what we discussed till now. How? Because the presence of the current source reduces the number of equations. So, because of this the number of equations would be reduced and it is much easier to solve these kind of circuits. Now, to analyze these kind of two circuits, let us take two examples, rather let us take two cases first, so that you can understand two different types of circuits containing the current sources. First one is that when current source exists only in one mesh. So, in this particular case you will see that the current source exists only in this particular mesh. So, this is 5 ampere for this particular mesh. This mesh contains voltage source. So, if you see these kind of circuits, what you will do? You will set current I 2 is equal to minus 5 ampere, because the direction of I 2 we have taken as clockwise as we have taken for I 1, but the current source is opposite to what we have assumed the current for I 2. So, that is why what we will say? We will say I 2 is nothing but minus 5 ampere. So, this you can easily verify from the figure, because I 2 will flow in this direction and the current will from the current source will flow in this direction. So, I 2 would be nothing but minus of 5 ampere. Now, we got the value of I 2 straight away through inspection using this figure. What we have to do next? We have to next find out the current in other mesh. So, you have to just write the mesh equation for this particular mesh. So, what you will write? You will write simply minus 10 plus 4 into I 1 plus 6 into I 1 minus I 2, and that would be equal to 0 for this particular mesh. Now, since we already know that I 2 is equal to minus 5 ampere, you can simply put the value of I 2 in this equation and you will get current I 1 as minus 2 ampere. Now, that particular case was relatively simple, because mesh the current source was in only one mesh. But suppose if the current source exists between two meshes where the both of the meshes are sharing the current source, then what you have to do? You have to analyze the circuit by creating a super mesh. Super mesh means you have to exclude the current source and any element connected in series with that particular source. So, in this case if you see, this is the segment which has current source and one 2 ohm resistor connected in series with the current source. So, for our analysis what we will do? We will remove this particular branch from the circuit while keeping the mesh currents same. So, like in this case we have two meshes, we have assumed that both are in the clockwise direction with I 1 and I 2 values. So, currents will remain same, but the link between these two meshes have been removed, because it was containing the current source. Now, what we get? We get a super mesh which contains two meshes, and we have removed the current source and created the super mesh. So, what will happen in this case? Super mesh would be the mesh having all the elements except the branch which we have removed. So, in this case this would be the super mesh, but there might be few cases where we may get two or more current sources, and then in that case we may get two or more super meshes. So, in that case what we have to do? We have to combine the super meshes who are intersecting. So, this is important thing, that if two super meshes are intersecting, then only we can create a larger super mesh. So, this particular this particular aspect we will discuss with one example. Now, let us understand how the super mesh will help in solving the circuit. Now, super mesh is required to be created because mesh analysis applies to KVL, and the KVL requires that we should know the voltage across each branch, but when we have the current source, it is difficult to stabilize the voltage across the current source in advance. So, what we will do, we will use the super mesh and apply KVL to that super mesh. So, in this case, if you apply to super mesh, what will happen? It will start with minus 20 plus 6 I1 plus 10 into I2 plus 4 I2 equal to 0. Now, if you solve it, if you simplify it, you get 6 I1 plus 14 I2 is equal to 0. Now, you have got one equation using super mesh, but since we have two variables, we need more than one equation to solve it. So, how we will get the second equation? We will get the second equation with the help of Kirchhoff current law, which we will apply to a node where two meshes intersect. That means, we will apply at this particular point. So, now if you see this particular node, what you can see? You can see I2 is coming in and I1 and 6 ampere current source are going out. So, you can simply apply Kirchhoff current law and say that I2 is nothing but I1 plus 6. So, now you have got another equation. First is this equation, second you have got from the Kirchhoff current law. Now, if you see these two equations, it is very easy to solve. You get the value of I1 as minus 3.2 ampere and I2 as 2.8 ampere. So, with this you can easily solve these kind of circuits where you have current sources connected in the network. So, let us see one example so that you can understand what we discussed about the super mesh and larger super mesh. So, let us take this circuit. This circuit contains one dependent current source and one independent current source, right. Now, we have to find the values from I1 to I4. So, if you see this circuit, you will have 4 meshes created. So, that is why we have 4 mesh currents like I1, I2, I3 and I4. So, now what you will observe, that there are 2 current sources. So, what we discussed previously, if you apply that particular technique to find out the super mesh, you will first remove this particular link. So, what will happen? You will get one super mesh like this, right. Now, we know that there is another current source. So, if you remove this current source, you will get one super mesh as this one, right. Now, the problem is that these two meshes are crossing each other. So, what we discussed, that if you have this kind of scenario where two meshes are crossing each other, we have to merge both of them and create a larger super mesh. So, what will happen in that case? You will get another super mesh, which is the union of both of the super meshes, and you will call it as larger super mesh. So, now you get this larger super mesh. What you have to do now? Larger super mesh can be used to apply Kirchhoff voltage law. So, if you apply Kirchhoff voltage law for the larger super mesh, what you will get? Let us start with 2 ohm resistance. You will get 2 times of I1 and then 4 times of I3, then 8 into I3 minus I4 plus 6 I2, right. So, this is what you got from the Kirchhoff voltage law. Now, you have now two current sources. So, what you have to do? You have to apply KCL at two nodes where these two current sources are connected. So, for node P, if you apply Kirchhoff current law, and if you see the mesh current is I2, which is going in to node P, and the mesh current I2 is coming out of node P, and another current source of 5 ampere is coming out of node P. So, what you can write? You can write I2 simply as I1 plus 5. Now, you have got the second equation, this was your first equation. The third one which you will get is using KCL at node Q. So, here what you can say for node Q, I2 is nothing but I3, this is I3 plus 3 into I0, because these are coming inside the node and I2 is going outside the node. So, 3 I0 plus I3 would be equal to I2. So, here you got 3 equations. Now, unknowns are how many? Unknowns are 4, I1, I2, then I3 and I4. So, where we will get the fourth equation? Fourth equation we will get by creating the, by writing the equation for this mesh, right. Now, if you see this mesh, I4 is nothing but minus of I0, because I4 and I0 are in opposite direction. So, if you see this, you will simply get I4 is equal to minus of I0. Okay. So, now if you put this value here, you will get I2 is nothing but I3 minus 3 I4. So, it is simplified now, but still we need the equation for this mesh. So, what we will write? We will write KVL for this mesh. So, what we can write? 2 into I4 and plus 10, because it is, we are going from plus to minus, so it will become plus 10, and then this will become 8 into I4 minus I3, and this will be equal to 0. So, you will get another equation here. Now, what you have to do? You have to utilize this, and anyway we have utilized this and put the value inside the equation 3, and we have got I2 is equal to I3 minus 3 I4. So, you take this equation, this equation, this equation and this equation. So, you have 4 final equations and you have 4 unknowns. So, you solve these 4 equations, you will get the values for current I1, I2, I3 and I4. So, if you follow the concept of larger super mesh and the super mesh, it is very easy to solve these kind of circuits, which looks little bit complicated when you see them for first time, but it is very easy to handle it. The important thing which you have to remember is that since it is a dependent current source, you have to find out how the value of this dependent current source would be calculated. So, here the dependent current source value is depending upon the current which is flowing from the voltage source. So, with this value, that is what we calculated, that I4 is equal to minus I0. It was easier to put the value in the dependent current source and do the analysis. So, with this we close our today's session. So, today we discussed about the mesh analysis and particularly the case where current source is available in the mesh analysis. So, in the next class we will discuss about the node analysis, because that is where we will apply our Kirchhoff current law and analyze the circuits where voltage sources are there. Thank you.